Good morning everybody. So now I am going to present a lecture on double integration. So this is a video lecture for the program BSc, subject Mathematics, semester 5, session 47. So this is the learning objective. These are the course outcomes. These are the prerequisites: differentiation, basic rules of differentiation and integration. So let us start double integrals. So first we define what is a double integral. So to define this, consider a function f of xy, that is a function of two variables f of xy of the independent variables x and y, which are defined at each point in the finite region R of xy plane. Now divide this region R into n elementary areas of delta A1, delta A2, delta and dash dash up to delta An. That means you have to divide the region R into a smaller parts, and each part is having an area of delta A1, next is delta A2 and so on up to delta An. So divide the region R into n elementary parts whose areas are delta A1, delta A2 and so on up to delta An. Now let xr, yr be any point within the rth element area delta Ar. Now consider the sum f of x1, y1 delta A1 plus f of x2, y2 delta A2 plus dash 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 up to plus f of xn, yn delta An. That is, in summation form we write this as summation from r is equal to 1 to n f of xr, yr delta Ar. Now if the limit of the above sum, means this sum, if the limit of the above sum exists, then it is defined as the double integral of f of xy over the region R and is written as double integral over the region R f of xy dA. Thus, double integral over the region R f of xy dA is equal to limit as n tends to infinity, delta A tends to infinity, summation from R is equal to 1 to n f of xr yr delta R. So call this equation as 1. Now for the purpose of evaluation, this equation 1 can be expressed as the repeated integral, integration from x1 to x2, integration from y1 to y2 f of xy dx dy, and its value is found as follows. So that is, first one, when y1 and y2 are functions of x and x1 and x2 are constants, then f of xy is first integrated with respect to y, keeping x fixed between the limits y1 and y2, and then the resulting expression is then integrated with respect to x within the limits x1 to x2. So that is, I1 is equal to integration from x1 to x2, integration from y1 to y2 f of xy dy dx. Similarly, if x1 and x2 are functions of y and y1 and y2 are constant, then f of xy is first integrated with respect to x, keeping y fixed between the limits x1, x2, and then resulting expression is integrated with respect to y within the limits y1 to y2. Or we can write I2 as integration from y1 to y2, integration from x1 to x2 f of xy dx dy. Okay, so let us solve now problems. Evaluate a double integral, integration from 1 to 2, integration from 0 to x into x plus 2y dy dx. Now see here, whereas this y is a function of x, y1 and y2 are functions of x, whereas x1 and x2 are constant. So therefore, first we integrate with respect to y and then with respect to x. So therefore, integration from 1 to 2, integration from 0 to x, x plus 2y dy dx can be written as integration from 1 to 2, then we first differentiate with respect to y. So differentiation of x dy is xy plus differentiation of integration of 2 into integration of y is y square by 2. So 2 to get cancelled, so that is y square, limit from 0 to x dx. Now we substitute the limits, then we integrate with respect to x and then we get this is 14 by 3. So this is the value of the given double integral. Similarly, we have another problems which are left as an exercise for you. So second is the value of the double integral, integration from 0 to 1, integration from 0 to 2 x plus y dx dy is, first option is 2, second 3, third 5th, fourth one none. So you have to choose the correct answer by solving the given problem. Now third one, the value of the double integral, integration from 1 to 2, integration from 0 to 3y y dx dy is, first option is 2, second is 4, third is 7, fourth one is none. Similarly here, fourth problem we have the value of the double integral, integration from 0 to a, integration from 0 to b, x square plus y square dx dy is, first option is ab by 2, second option is a plus b by 2, third ab by 2 into a square plus b square, fourth is none. Next, fifth one we have the value of the double integral, integration from 0 to 3, integration from 1 to 2 xy into 1 plus x plus y dx dy is, the first option is 2, second one is 30 into 3 by 4, third is 5, fourth is none. So you have to choose the correct answers for all of these problems by solving the problems. So these are the reference books. So with this I conclude my session and continue in the next session. Thank you.